So direct or partial. Now we call the variations direct or partial
Mm-hmm.
in the context of a line.
Mm-hmm.
For example, y equals to 3x. This is the equation of a line, which is going to look like slope is that. What is the y-intercept in this line? The y-intercept is not there, so you can write plus 0 if you want, but we gonna just keep in mind if there's no constant, that means y-intercept is 0.
Mm-hmm.
Good. So my b value is 0. My m value is 3, the slope. So b0 means this is the
So m
point.
is the slope.
M is the slope. Now b0 means you're starting it from this point, right? That's the starting point. And the slope is 3. B is 0. Slope 3 means you do rise. Rise by 3, 1, 2, 3, run by 1. So you rise and then you run. You end up there,
Mm-hmm.
and then you do 1, 2, 3, right? Now, any line which have b0 is known as direct relation or variation. The
So
line is
this is
very,
direct.
yeah, this is a
And how
direct
do you know which
variation.
is variate
Just by
part?
looking at the b part. If your b is 0, that means the relation is known as direct variation. There's a variation, right? Line is traveling up, so line is changing its y value when x values are changing.
Mm-hmm.
So as you choose different x value, you're gonna get different y values. For example, if I choose this x value, for that x value, my y value is approximately there. For the next x value, which is right there, y is gonna be up here. So the y is changing as x is changing. So with a slight change in x, we have a slight change in y.
Okay.
So that is the direct. And now the partial is gonna be a variation which is not starting from an equation which is not starting from 0 0 is gonna give you a partial variation. For example, let's draw related to the partial. Um, mm, mm. So that was in the context of a line. We can do one more example in the context of a line. Now, this equation 4, if you look at that equation, it doesn't look like y equals to mx plus b, right? It doesn't look like that. So we call it standard equation of the line. This is standard.
Okay.
Now, what do we do? Actually, it's a general. Whenever your constant, everything is on the left hand side. We call it general equation of the line. We can convert it to this form. So then we can identify the b value. Now what we're gonna do, we keep negative y here and send rest of the numbers or the terms to the right hand side. 3x moves to the right hand side. You get negative 3x. You move y forward to the right hand side. You get negative 4.
Mm-hmm.
Now you multiply both sides by negative sign. Or you can say multiply both sides by negative 1. When you put a negative sign in front of a bracket, it's going to change all the signs in. Do you know that? This negative goes in, and then this negative goes there. Plus 4. On the left side, we have two negative signs, so y equals to that is the equation of the line.
Why are you multiplying minus by this?
Because in order to make y positive,
Oh.
so if you look at in this equation, y is positive, right?
Mm-hmm.
So I just want to make this whole thing positive. That's why I
So you're timesing by every number.
Yeah, I put negative sign in front of both sides, on the left side and on the right hand side.
Mhm.
Now, the b is not 0. B is 4. That means this line is not starting from the origin. It's not starting from right there, but one, 2, 3, 4 from there. The line is starting from there. So the initial value is not 0. So whenever your initial value is not 0, we're going to call it partial, partial relation. So this is the example of a partial relation. So the equation of the line is still same. I mean, the slope is still same as we had in the previous one. Slope is 3, so you do rise by 1, 2, 3, run by 1. Sorry, I'm using something else. So rise is 3, run is 1. So the line is going to look like that. So it's not about the line. They are asking you if this relation is a, if this variation is a direct or not.
So like
So,
which is the rise and which is the run?
so rise, let me write down the m. M is 3, right? That's my m value.
Mhm.
So you have to write that number in a fraction form. So 3 can be written as 3 divided by 1. So whatever you have on the top, we call it rise. Rise by 3 and run by 1.
Mhm.
Rise 3 means you go up. Now, sometimes your slope is gonna be, for example, if your slope is negative 2 over 3, now your rise is minus 2. What does it mean? That means you go down by 2 units.
Oh.
For example, if that's your y-intercept, you're gonna go down by 1, 2, and then you run by 1, 2, 3. So the slope negative means you go downhill. Slope positive means you go up like that. So whenever your m is negative, you're gonna fall down like that. So your rise is basically downwards, right? If
Mhm.
m is positive, it's gonna go up.
Okay.
So now we were talking about the relations. So whenever your initial value is 0, we call it direct. In other words, your graph is gonna start from origin, which is right there. And if the graph is not starting from origin, it's starting somewhere else, that
Mhm.
means the initial value is different from 0, then we call it partial relationship or
Oh,
partial variation. Good?
I get it. Yeah.
Now the next thing is in the context of a parabola, for example, y equals to x squared plus 1, negative 1. Now, probably you don't know how to draw that parabola because you're in grade 9,
Yeah.
right? So, if you don't know that, just substitute x as 0. Why we do that? By substituting x as 0, you're gonna find out the y value. If I substitute x as 0 in that equation, my y is gonna be 0 squared minus 1, which is minus 1. So the y value is minus 1 when x is 0, right?
Mhm.
So my my parabola is gonna start, or it's gonna pass through this point. When x is 0, y value is minus 1. So we call it y-intercept. So y-intercept of the parabola. Now this is a parabola. How do you know that this is a parabola? Because your second power is, your degree or the maximum power is 2. Whenever your maximum power is 2, in any equation, power 2 is going to give you a parabola, and parabolas look like that. These are the parabolas.
Oh.
So your parabola is going up and passing through this point. It's going to look like that, roughly goes up, right? So this parabola is not passing through the 0, 0, which is right there. Rather, your parabola is passing through non-zero, which is negative 1.
Uh huh.
So the variation in this parabola is direct or
Oh.
partial?
Partial.
partial. So we have partial variation in that problem. So that was the concept related to all those things, and they can ask you in any context. So if you have some more complicated equation, simply put x is 0, because x is gonna give you, whenever x is, now x is 0 here, x 1 2 3 4, when you substitute x 0, you're gonna get the y value, you're gonna find the y value, or you're gonna find the y-intercept. So in order to find the y-intercept, you substitute x as 0. In order to find x-intercept, you put y 0, because um, y is 0 right there. Y is gonna be 1 2 3, -1, -2, -3, and y is 0 right there. So in order to find x-intercepts, you put y 0, and in order to find the y-intercept, you're gonna substitute x 0. Make sense to you?
Yeah.
So let's stop this thing here.